Hello everyone and welcome. Ever wonder why some chemical reactions that look similar on paper happen at vastly different speeds? Or why molecules twist themselves into specific shapes? A huge part of the answer is a fundamental concept in organic chemistry called the steric effect. In simple terms, the steric effect is all about personal space, but for atoms and groups of atoms within a molecule. Imagine a crowded room. People take up space, and if it gets too packed, they start bumping into each other, which is uncomfortable. Molecules are the same. Atoms have electron clouds that occupy a certain volume. When these bulky groups are forced too close to one another, their electron clouds start to repel each other. This repulsion is the steric effect, and it has major consequences for a molecule's shape, stability, and reactivity. Let's break it down. First, the steric effect influences molecular shape and stability. Molecules will naturally twist and bend to arrange their bulky groups as far apart as possible to minimize this repulsion. A classic example is cyclohexane. A large substituent, like a tert-butyl group, will strongly prefer the equatorial position, sticking out to the side, over the axial position, sticking straight up or down, because the equatorial position is less crowded. This arrangement with less steric strain is lower in energy, making the molecule more stable. Second, and perhaps most importantly, is its effect on reactivity, which we often call steric hindrance. This is when bulky groups physically block a reaction site, preventing other molecules from getting close enough to react. Think of it like a bodyguard blocking access to a celebrity. A great example is the SN2 reaction, which requires an attack from the backside of a carbon atom. If that carbon is attached to small hydrogen atoms, the path is wide open, and the reaction is fast. However, if that carbon is attached to 3 large methyl groups, as in tert-butyl bromide, those groups act like massive bodyguards. They completely block the backside, making it impossible for the attacking molecule to get in. As a result, the SN2 reaction simply doesn't happen. So, in summary, the steric effect isn't a chemical bond or a mysterious force, it's the very real, physical consequence of atoms taking up space. It dictates how molecules arrange themselves for maximum comfort and stability, and it can act as a gatekeeper, determining whether a chemical reaction can even occur. Thank you so much for watching. If this explanation helped you understand the steric effect, please consider giving this video a like and subscribing to the channel. Your support is greatly appreciated and helps me continue to make more chemistry content. Let me know in the comments if you have any questions or what topic you'd like to see covered next.